Okay, in this video we're going to have a look at the electrolysis of copper sulfate solution, and then it's going to be a kind of two-part video. This one here we're going to use graphite electrodes, and later on we'll have a look at using different electrodes. So it's a solution of copper sulfate using graphite electrodes. Before we get into this, let's just remind ourselves of a couple of key things. First of all, ionic compounds, when they are solid, they do not conduct electricity. Why not? Hopefully you're remembering that ionic compounds have an ionic lattice, and therefore the ions are held in place and not free to move, and this means that they will not conduct electricity. But if we heat them up, make them molten, or if we dissolve them, as we are going to do here to make a solution, then the ionic compound will conduct, because the lattice has been broken by doing one of these two things, meaning the ions are free to move, and therefore it will conduct electricity. Before we get into the video, it's worth having a little recap of some key words as well. We're going to be using these words in our answer, so we need to make sure we understand what these words mean. So electrolysis, if you remember, this is to do with charges, and lysis, this is breaking down charged compounds, so breaking down ionic compounds. And to do that, we use a DC current. Okay, so the true definition is ionic compounds are broken down, decomposed into simpler substances using a DC, direct current power supply. Electrolyte literally means loose charges, so this is where we take ionic compound and heat it up or dissolve it so the ions are free, loose to move. Cations, cats and positive, I love them. They are the positive ions. Anions, an N in there for negative ions. The cations head towards the cathode. Remember, the youth go to the youth club and the old age pensioners go to the OAP club. So the cations go to the cathode. If they're positive, this must be negative because opposites attract. And the anions go to the anode. So if they're negative ions, then they go to the positive anode. Oxidation and reduction. Remember, this is about electrons. So if we, it's probably worth sticking another word in there. And the word I'm going to put in there is oil rig. So oxidation is loss of electrons, reduction is gaining electrons. So that's your little recap of some key terminology. We're now going to go into the video to explain how we apply this now to the example of the electrolysis of copper sulfate. Okay, so to do the electrolysis of copper sulfate, we're going to use graphite electrodes. The question is, why graphite? There's two reasons. Number one, graphite, you should remember, is a giant covalent structure, macromolecular structure, and it contains carbon, and the carbon inside the graphite has 3 bonds. If I was to jig your memory with a little picture, then I would sketch you something that looks like this. This is graphite. Remember, it exists in layers, and graphite is a good conductor of electricity because within this, each carbon has 3 bonds. You know that carbon wants to make 4 bonds. Therefore, it's got delocalized electrons, which can move through the structure, allowing it to conduct electricity. The second reason we use graphite is inert. Inert means unreactive. We don't want the electrodes to be part of this reaction, so we need them to be inert, unreactive. And there are 2 reasons why we have graphite electrodes. Okay, let's have a look then at what this means. Let me bring in a second sheet of paper for you. So here we've got our copper sulfate AQ, remember means solution. Let's break this into the ions. So the fact that we have got copper sulfate as the ionic compound is going to give us copper ions, Cu2+, and sulfate ions, SO4, 2-. The fact we've got aqueous, remember aqueous means dissolved in water to make a solution, means we're going to get H+ ions from the water and OH- ions. Okay, so in this reaction for the electrolysis, we're going to deal with 4 ions as the electrolyte as part of this electrolysis process. So here's the diagram showing you the setup. Okay, so we have our DC power supply that we need to do electrolysis. We've got our anode and we've got our cathode. Remember, these are going to be made from graphite in this example, and they are sitting in the electrolyte, which is copper sulfate solution. And as we've just seen, that means it contains copper ions, sulfate ions, hydrogen ions, and the hydroxide ions. So cations are going to head towards the cathode. So these are going to start to migrate this way. Okay, let's just focus on those for a second. 2 of them get to the cathode. Now then, only one of those can react. And we need to remember the order in which they react. To do that, at the cathode, we bring in our reactivity series. And on the reactivity series, you can see that copper and hydrogen are here, meaning that hydrogen is the more reactive of the 2. Therefore, at the cathode, it's the least reactive that goes first, reacts first. So in this case, it is going to be the copper that is going to react first because it's the least reactive. So at the cathode, I will end up with my copper ions, Cu2+. What will they do? They will pick up 2 electrons to form copper. This is now gaining electrons, so this process here is an example of reduction. And what I would start to see happening is on the electrode, I would start to see copper metal starting to form on the surface of the graphite as this reaction proceeds. Let's go back to the anode. So the anode is going to attract the anions, that's the sulfate ion, and the hydroxide ion are going to go that way. When they get there, who is going to react first? Same question, different reason why. Here, the sulfate has got 1s, 4o, so it's got 5 parts to it based on that formula. The hydroxide ion only has 2 parts, 1o, 1h, it's got 2 parts. So at the anode, it's the simplest that's going to go first. So it's going to be my hydroxide ion, it's going to react first. Check out the other videos if you've forgotten how to work this out. You just need to get this into your memory banks, that repetition of this information. That's the equation. Notice my hydroxide ion is losing electrons, so this side is oxidation. And what I would see happening here, this electrode, is because we've got oxygen gas forming, I would start to see bubbles of gas forming at this electrode as the oxygen forms at the surface. Okay, hopefully that helps. Please watch that video as many times as you need to help you complete the notes and the activities in your book.